All right, we are going to do some greatest common factoring. So we're going to have a polynomial. These are trinomials, but it works for any polynomial. So a binomial, 2 terms, trinomial, 3 or 8 terms, right? We're looking for greatest common factors. So we should probably have out our factor squares. Makes life a little bit easier. Oh, where am I? Back here. We have so many pages of notes, I just don't even know where we're going anymore. So I have my factor squares ready and out so that I can reference them. And I'm just going to walk through about 4 example problems with you right now. So write these down on a piece of paper, go over them with me, see if you can do it. So let's do the first one together, then maybe start pausing the video to see if you are getting the same solution as myself. So first one is going to be 25x to the 5th plus 20x to the 3rd plus 15x squared. So I'm going to over-explain, right? I'm going to show more work than we normally would. And so I'm going to make a list of these factors underneath here. So I'm going to talk through what these can be divided by, so then we can find what's the greatest number that they have in common. So I know that 25 can become 1 and 25, right? I can do 1 times 25 to get 25. I can also do 5 times 5 to get 25, right? And those are the only factors of 25. There are no other factors of 25. And I can make sure that that's true by looking at my factor squares. 20 can be 1 and 20. It can be 2 and 10. Or it can be 4 and 5. And then 15 can be 1 and 15 or 3 and 5. So now I'm looking to see what do they have in common. But before I do that, let's also do our x's, right? Our variable. So x to the 5th is 1, 2, 3, 4, 5, right? X to the 3rd, 1, 2, 3. And x squared is 1, 2. With me so far? So now let's see what they share. What do they have in common? So if I look at my list of factors, I know that all 3 have a 5 in common. So my greatest common factor, my GCF, now if there were 2 numbers in common, right? Or if I was prime factoring this, yeah, I could do this a little bit differently, but since I'm just doing straight up factors, I'm looking to see what can they all be divided by. And then they also have 1, 2, 3, 1, 2, 3, 1. Uh-oh, not 3. I'm going to have to take away, let me get my eraser. They only have 2 x's in common. Where did my green go? They only have 2 x's in common. So my GCF, what they all have in common, what they can all be divided by, is 5x squared. So that's my GCF. So I'm going to come over here and I'm going to do 25x to the 5th plus 20x to the 3rd plus 15x squared. And I'm going to divide all of those by 5x squared. Because I'm taking that greatest common factor out. Well, 25 divided by 5 is 5. And x to the 5th divided by x squared, we subtract our exponents, is x to the 3rd. And 20 divided by 5 is 4, positive. And x to the 3rd divided by x squared, we subtract our exponents, is just x to the 1st. 15 divided by 5 is positive 3. And x squared divided by x squared cancels out. So this is my solution. When I take out the greatest common factor, I'm left behind with this. So I'm going to write this down inside parentheses, and I put the greatest common factor out front. So here would be the solution. All right, let's do another one. Magic erasers, guys. They're the best. All right, so let's do one with a leading negative coefficient. So let's talk through that. So we have negative 9x to the 6th plus 54x to the 5th minus 36x to the 4th. All right, so my leading coefficient is negative. It's a no-no. We've got to get rid of it. So I'm going to take that negative 1 out, and I have to remember that. So I'm going to take this, and I'm going to draw, since I'm doing my work over here, I'm going to draw that over here, because I have to remember to put that negative back into it. So when I take out that negative, it means everything behind it changes. So it becomes positive 9x to the 6th minus 54x to the 5th plus 36x to the 4th. Everything behind it changed. So now I'm going to list my factors, right? I'm going to look to see what they all have in common. So 9 can be 1 and 9. It can also be 3 and 3, right? And again, if you don't remember factor squares, right? We wrote them down. And 50, what am I at? 54? Okay, here we go. 1 and 54. We have 6 and 9. We also, 54? 2 and 27. Anything else? Let me check my factor squares. 54. Oh, 3, right? 3 and 18. That's a lot of factors. All right, now let's go to 36. 36 has a lot too. 1, 36, 6, and 6. 2 and 18. Looking at my factor squares. 3 and 12. 4 and 9. Whew. So those are all my factors for 36. I'm not prime factoring. You could use prime factorization to find the greatest common factor. I'm just listing all the factors to see which one is the biggest that they have in common. Then I have 1, 2, 3, 4, 5, 6 x's. I have 1, 2, 3, 4, 5 x's here. And I have 1, 2, 3, 4 x's here. Good? What's the biggest number that they all share? Well, I can do my x's kind of off the bat because there are 4 here. 1, 2, 3, 4. 1, 2, 3, 4. So my GCF is going to include x to the 4th. And what's the greatest number that they all share? Well, let's see. The biggest number here is 9. So 9. Oh yeah, they all share a 9. Now let's double check. Do they share anything bigger? Any greater value? Any coefficient that's bigger, right? This number? No. So their greatest common factor is 9x to the 4th. Now remember, when I get done, I have to put that negative back in, right? But we're not there yet. So I'm going to take this because remember I took that negative out, so I changed my problem. It was 9x to the 6th minus 54x to the 5th plus 36x to the 4th, right? And divide by 9x to the 4th. 9 divided by 9 is 1. You can put a 1. X to the 6th divided by x to the 4th is x squared. I don't need that 1. It doesn't change it. Negative 54 divided by 9. Negative 54 divided by 9 is negative 6. x to the 5th divided by x to the 4th, right, is x. And 36 divided by 9, right? 36 divided by 9 is positive 4. And x to the 4th divided by x to the 4th is 1. Disappears. So this is my answer. This is my leftover. And I'm going to put my greatest common factor in front. 9x to the 4th. But remember, I drew this little arrow for a reason. I took out a negative at the beginning, so I have to add that negative to my greatest common factor. Boop. There's my answer. Again, if you didn't want this, oh, don't erase the x. You don't need that one in there. All right, 2 more. This chair is a little too squishy for me to be working in. I'm relaxing too much. All right, let's do a negative. Negative 18 p squared minus 20p minus 16. All right, so if you want to try it on your own, totally can. Pause it, and then do the problem, and then come back, press play, see where you're at. Or just follow along with me. First thing, negative leading coefficient. Let's take that out. Negative 1 leaves behind positive 18p squared plus 20p plus 16. Everything changed behind it. I'm going to draw, and I'm going to remind myself that I took out that negative later. All right, factors of 18. Here we go. Again, this is, where am I? This guy right here. It's fantastic. Use it all the time. 18 is 1 and 18, 2 and 9, 3 and 6. 20 is 1 and 20, 2 and 10, 4 and 5. 16, 1 and 16, 2 and 8, 4 and 4. P, 1p, nothing. So they don't share a variable. We cannot factor out a variable. So my greatest common factor, GCF. The biggest number over here is 18. Did they share an 18? Nope. Biggest number is 9. Nope. 6. Nope. 3. Nope. 2. The greatest common factor is just regular old 2. Sometimes it's just a number. Sometimes it's just a variable. Sometimes it's variables and numbers. Here we go. 18p squared plus 20p plus 16 divided by just 2. 18 divided by 2, 9. P squared, because my variables aren't going to change. 20 divided by 2, positive 10. That p just comes along for the ride. And 16 divided by 2 is positive 8. I'm going to put my GCF in front. And remember, in this problem, that's why I draw this arrow to remind me I took out a negative at the beginning, so I'm going to have to go boop for negative. Getting better? Hopefully? All right, let's do the last one. I keep covering up my work. Ooh, this one's interesting. 27 m to the 7th plus 27 m to the 4th minus 72 m to the 3rd. My leading coefficient's positive. It's in standard form. Sometimes you have to check that. It is in standard form, so we're good to go. So let's talk factors. 27. 1 times 27. What else? Oh, you don't know? Could you use your factor squares that you wrote down? I bet you could. 3 and 9. 27. 1 and 27. 3 and 9. 72. Ooh, hey, ooh, ha. 1, 72. 2 and 36. 3 and 24. 4 and 18. 6 and 12. 8 and 9. It's a lot. Okay. Let's see what they have. Oh, no, I forgot my variables. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3. What is the largest number that they share? 27. 27. No, 27. 9. 9. 9. So they all share is 9. They all share 9. And they all share, start smaller. 1, 2, 3. 1, 2, 3. M to the 3rd. Let's factor. 27 m to the 7th plus 27 m to the 4th minus 72 m to the 3rd. It's my original problem. I'm dividing by my greatest common factor. 9m to the 3rd. 27 divided by 9 is 3. M to the 7th divided by m to the 3rd is m to the 4th. 27 divided by 9 is 3. M to the 4th divided by m to the 3rd is m. And negative 72 divided by 9 is negative 8. M to the 3rd divided by m to the 3rd cancels out. It's 1. Here's my leftover. Put it in parentheses. And my greatest common factor goes in the front. All right. Factoring out greatest common factor. Very important because the next skill, factor by grouping, you also do greatest common factor of each half, right? So greatest common factor is super important. You are going to get to the point, I believe, I know you will. You are very smart people. That you don't have to write all of these factors. That you could just be looking at your factor squares and pick out the greatest common factors. Sometimes you just go through and you know the greatest common factor just by looking at it because they're values that are common to you. Guys, look at the cat. I had to create some toys for her to play with so that she didn't bother me. She's nuts. But you're going to get to the point where you don't have to list all of this stuff. You can just visually see it, or it's gonna be through repetition. It's just gonna get easier and easier and easier. We are gonna be factoring for a while because the factoring even goes into our next unit, right? We're gonna solve by factoring. So having those perfect squares, or not perfect squares, having your factor squares out and about and ready to use is really important. I will repost a picture of the factor squares just so that we have it again. All right, good luck. Email, let me know if you need more help. Bye.